Welcome everyone to more live Linux distribution development. I want to continue a little bit. Yes, also microkernel, I'm aware of that. But also kind of sort of finalize, except yeah, it's never final, it's never done, right? There's always one more thing, and with one more thing comes another thing, but sophisticated testing strategy. I started this already some months ago. We haven't really done something yet. It's only started to adhere some sorts. So we are building here, also we need to restructure this code a little bit. This is my build it all front end driver for our Linux distribution stuff. And we also need to shuffle this code a little bit around because we need here, I said here QEMU for other architectures, but we need to do this later. So we need unfortunately this case block here again. Because we need to see what other configuration we have for 32-bit default and stuff. But so the point is, why do we want to do this? Because we support 24 architectures and counting and increasing, like ARM, Super H, PowerPC, all the crazy stuff that at times only we support. Not to mention Motorola 68K. And so we want to test. So what do also, because it certainly doesn't scale, even if we would have hundreds or thousands developers, certainly nobody with a sane mind would want to each time with a release gets a hardware constantly, or like continuous integration testing, or at release time gets a hardware out and do the testing. So we need to automate this. And of course nowadays with virtualization, nowadays with QEMU, like nowadays only for 15 years. That is certainly a huge improvement, right? Just the last 10 years with virtualization emulation. So we basically want to test most things with QEMU. And so what do we want to test? So also this is the wrong file. What we want to test, I made here already some notes. We want to test what usually we know at times fails. So except extracting all the tarballs, what usually should work, as it's a little bit in parentheses here, because sometimes I control Z and stuff and control Z and control Z and stuff. So sometimes, very rarely, but sometimes it can happen that with all the rapid development stuff, I ruin some tarball with killing this just with creating the tarball. That is also, maybe we should actually, I should check whether, actually we should even check if all are there. Not that we compress into some file, but even so, if we ignore this, then the most important, this is like the lowest hanging fruit. Like we do the sophisticated stuff first, not the lowest hanging fruit. So basically, I shouldn't touch the build. If I don't touch the build, then all the release tarballs are there, obviously. But so the most interesting stuff, our test that this binaries run. What we constantly have. What is the issue? The issue is that either new compilers, especially for vintage and retro, we are the last people who test this. Some stuff for Itanium we even need to build with -- enable obsolete. So it's like, yeah, and they want to remove it upstream, but that's not the biggest thing. We will just keep the last working version around. So we want to test with QEMU that the binaries have a chance to work, right? So basically we want to test like from the lowest level, do the binaries even work? Obviously nowadays we do this with QEMU. It's also testing QEMU, by the way, because sometimes I had the issue that the binaries actually do work, but they don't work in QEMU because we are so often the only people who try that. Like Spark 64, like what was it, Spark 32 V+, whatever the exact name of that QEMU variant is, was often segmentation faulting, as was MIP 64 at times. So we would also need to gather, or actually we are basically also testing QEMU. We are heavily testing QEMU with it, and we can't test all with QEMU, right? This is why I started to have here, not here, but what you saw a second ago, I basically started to assign here QEMU. Usually QEMU is, of course, we default to QEMU dash architecture here somewhere, like here, like QEMU arch, and except when it doesn't, because we use PowerPC and upstream uses PPC and stuff like that. So and also some stuff is endianess here, for example. So some of the stuff is additional translation, and we would even need to further conditionalize the stuff, whether we build 32-bit default, it's Spark 32 plus what I just meant. Did I got this right? Maybe nearly. So basically, I finally want to do that, and so that's basically the test plan. What I was thinking the last weeks, right? Make sure that the freaking binaries actually even work and not like segmentation fault, and then that the init ID works, because it is also a rather complex process, and at times we have multi-lib variants, so sometimes we packaged init IDs with incomplete or not matching shared objects, unfortunately. Sync MIPS, we have MIPS 032, N32, and then like the matching libraries are packed and stuff. Not that we have regressions or other changes or GCC builds the wrong stuff and stuff like that. Test boot the kernel. Unfortunately, that doesn't work for all architectures. I mean, all of this stuff doesn't work for all architectures because not all have QEMU. I mean, theoretically, I could stack their real hardware and like network boot that. That's certainly, by the way, did I here? Network boot real hardware, theoretically. But first we do the QEMU stuff. The more we can do with QEMU, the better. And then the handful we can't test, like hopefully they do work. Famous last words. So boot the kernel. Booting the kernel doesn't work for all architectures, even if we have QEMU, because not all architectures have universal generic kernels. So for example, MIPS, yes, the vintage and retro stuff for our Octane. I mean, this is also the stuff I would develop it differently, and we will soon do our microkernel. That is like ARM, all this board-specific things. I really hate this, not relocatable, and even not only interrupt handling and differences and memory mapping, and then also relocatable and even needs to load to different addresses on the various machines for completely stupid reasons. So we don't even have one SGI kernel. We would have one O2, one Octane, one Indy and stuff kernel. There probably is a generic QEMU kernel and config, and there also this longsome config for this Chinese MIPS CPU thing. So yeah, totally not amazed with this stuff. My microkernel will be better, but I first still need to write it. So we can't boot our kernels, so we will test x86, maybe some ARM, at least 64, RISC-V probably. Hope, yeah, it probably should work. Some PowerPC. So we have one generic PowerPC kernel, or like one for 32-bit and one for 64-bit. So we can test both in QEMU. It will, of course, not. It will boot more like an emulated Macintosh, not like a P3, but it tests already generic stuff, important things. Yeah, we should also test the low memory install. This is also a recurring theme, right? That we build stuff and it gets bigger and bigger, and then it doesn't boot on low memory things like the P3 or other vintage stuff. What I think we probably should target like 256 megabyte. This of course means, yes, this is huge. It's also because the init RDs have so freaking many drivers nowadays, plus all the user space, so that is a bit crazy. I wonder if we could optimize it a little bit, though. Previously, I think decades ago, the memory requirements for our Rock Linux T2 stuff was way lower. I think we directly mounted the CD. So I guess if you don't, Anyway, it has not the highest priority. Right now we will not further optimize it. Right now we will only test it. It has a chance to boot with it. Then further tests, GCC can compile and produce working executables. That all of this stuff sounds basic, right? But I had this even multiple times for Spark 64 and also MIPS or so, and maybe even x32, like the exotic combinations, that sometimes the default 32 versus 64 wasn't configured or patched in a way for binutils and GCC to match and produce working binaries, so that it would have worked, but like GCC built 32-bit and then GNU assembler and linker complained like, yeah, this is an incompatible object format and stuff, and you would need to build this with -m emulation, whatever, and so on. So yeah, that should work. But this, yeah, so this will be other tests. Also, by the way, run basic binaries like ls, and also maybe even, so we would want to test this gradually to know what is failing, right? We could, I mean, not only we can't put all the stuff in QEMU, I mean, we could theoretically like have one test script, like even as complex as scripting the whole installation, and at the end build a binary. The only problem is that it's also super complex, right? It sounds easy, script tool installation, but we tried this also some months ago. Even scripting Zool installation is a rather complex affair with all the timing and output, different output and partitioning and stuff. So it also takes long and stuff, and then you don't know what exactly failed and so on. So this is a much more granular approach. And you then now with this kind of, I mean, obviously in any sophisticated kind of software, you would want to have some significant amount of test coverage. Let's say, I mean, holy grail of 100% test coverage, which obviously even Apple and Microsoft don't have. But this is fine-grained tests. You also know what fails, right? If you would boot all, like have only like one huge installation script and at the end like run GCC and stuff, then you would not necessarily know what kind of step failed, and testing this step by step, run basic binaries and run more complex binaries so that you have already an indication of what fails. Does the basic stuff work, linker, compiler produces working code, dynamic linker works and so on. More complex stuff, complex stuff like bash and find. So I write here find because 15 years ago find had a major bug that even resulted in major havoc of even deleting rock Linux sources. So this is why I'm not saying that find, I mean, since 15 years find did not, I personally didn't experience such a major regression, but it would be some more complex things of using more system calls and so on. So this was also at times the case that like most stuff worked, but some more complex stuff didn't. So we can basically like test number one, does the basic binary stuff work? Test number two, does some more like complex stuff not work? And then you already immediately get some feedback. What kind of stuff fails? Is it the most complex stuff, the most basic stuff? Is it a little bit more complex stuff, a little bit more exotic system calls and stuff? So yeah, then even X, maybe even Valent, I wonder, is there some virtual, so for X we can use X virtual frame buffer. So with that we could, we could even test Firefox. Start Firefox and see that it really comes up and doesn't segmentation fault. Although we would need to check how to configure user mode QEMU to actually get that up. Okay, that is still in there. There's also a second option of configuring the regular Xorg server. I mean, this could even be two steps, because we could, oops, shit. We could, one thing is use local, so we basically, so this would be, that would be that the X binary works, so yeah, I mean, this probably, do I have here? I don't. So basically this would be test X server, maybe X virtual frame buffer, or, I mean, theoretically maybe in the future both. It is always how much you want to do. So basically that the Xorg server can start. Probably, I mean, maybe most people use X virtual frame buffer thing, but you could potentially also, yeah, they say as 2016 was slated to be replaced by using dummy drivers, video dummy and input dummy drivers. The benefit of that certainly is to use more regular code paths and make sure that the core component of Xorg server work instead of this custom binary. I wonder, do they have some virtual Wayland? Probably, I read they have virtuality. They have at times VNC support. Interesting. Sway supports this. It's Wayland backend set to headless without any Sway. Okay, I knew that Sway has VNC. Yeah, so Wayland, let's make you some notes. Let's already Wayland backends to headless and backend headless and VNC. And so even with that, I would hope that you run that with that headless backend, obviously, and then you could even start some stuff like Firefox or other terminals, other Qt, and then connect with VNC, make a screenshot, and also compare that, right? Either pixel perfect if you use the same fonts, which probably is the default. I mean, the problem is even the fonts with old bitmap fonts that was more straightforward. With new anti-aliased fonts, there is the issue that each major version, or sometimes even minor versions of free type, can at times anti-alias it differently, or other floating point and running, or but there are solutions for that, right? You can perceptually diff that, or either difference and compute the difference, and like if the difference is small enough for all the anti-aliased edges, or you use some sophisticated perceptual. There are perceptual difference algorithms to have this a little more perceptually human. I waited. Anyway, that's not the topic of today's video. Yeah, encrypted rootfs. There's also some crazy stuff going on. Yeah, so basically we should test everything. If you have something to test, as usual, leave in the comments below. Binary size sanity check. I think we recently checked that for PowerPC. So, for example, what was it? Even like, was it LS or something? Okay, that is actually rather, or was it cat? Okay, cat. It was probably like, e.g. bincat less than 64K, which probably usually it should be. If it isn't, then I mean, of course, you make tests for your expectations, right? If you intentionally create configurations or build stuff that, for example, statically link stuff, of course, if you statically link that with glibc, then it will be a freaking megabyte or stuff, or at least 720K or so. Probably not, maybe nowadays a megabyte, because obviously. But for our sane default configuration, what we had this recently, that for PowerPC everything was built for stupid upstream changes. Of course, we patched that into 2 because, of course, some people call us our best Linux distribution for a reason, obviously. So we patched PowerPC back to use 4K pages and not 64K pages, because all the freaking binaries were so large that not only it increased everything, but even the init.id, obviously, and then of all the stuff, also crazy stuff, right? Only for PowerPC they do that, including 32-bit, and then you can't even boot it on a P3 anymore because everything becomes so humongous. Did we discuss something? All right, I think I wanted to add Firefox. So test X server, like probably with some window, like I guess that would mean X term also. Also best was so yeah, theoretically even, or okay, GTK, because we don't have Firefox in all targets. So what we probably could do, as usual, that was a summary, right? Just to entertain you a little bit of ask me anything. Let's talk AMA session. We will not implement this all today. Not only is it too hot, but also too long of a live stream. Of course, you can share, like, and subscribe and stuff, and comment if you want to see all this stuff. So I prepared this already in my other project, like Mini SED or Exact Image, although the Exact Image test suite is not public for many reasons. I use a very simply, I've shown this already, but you can take a look at Mini SED. Just in Exact Image, it is similar. Again, it's not open source. Our test suite also for customer documents and image data and stuff. Also, it is humongous. I think our Exact Image test suite includes over a gigabyte, if not 2 or 3 gigabyte of image data in probably 100 tests, because we're professionals. But in Mini SED, it is quite similar. In Exact Image, it's just a little bit more sophisticated. It's totally the same concept, like some very shell. Actually, I should have that here probably. So some run driver. Again, we love to keep our stuff stupid simple, right? And I mean, why should I use sophisticated test suite packages if I can script some stuff in 62 lines? And what that does is, we have here the tests. How many do we have in mini-SED? In our little unsuccessful, yeah, 69 freaking tests. And actually, no, I'm wondering how many do we have in exact image. We have some more though. Also here they are called command, I think. Or even, did I say 100? I meant 100. These are not even all because we have here some more in subdirectories. I mean, with all PDF tests, do we have the PDF tests here? Maybe. Oops. Did I say 100 tests? I meant 800. Even that might not be all, because do we have barcode here of? Maybe we have some 1032 tests. Probably I should also not show the test names here. So not making this. Actually, these are more tests than I expected. I thought like ballpark of where we have 100 tests, like how we have 1000 tests. Engineer, 10x engineer. Yeah, this is, by the way, how you're doing this. Code that's not tested is buggy code. And I will do something similar here. The only thing is, it is in exact image, it is this command files that are pretty similar to mini-SED. I'm not sure which I did first. Did I first do mini-SED? Actually, maybe I first did mini-SED and then I copied to exact image and made it more sophisticated. These are, by the way, not even all tests. In our universal UI stuff, we have even more. There's also a command here, probably. How many tests do we have here? There's also 34. We should have more in subdirectories, I guess. Nah, 94. 100 tests there. Yeah, but the concept is the same, super simple, just to show you that you can test sophisticated stuff. Also, in my opinion, the more simple the stuff, the more stable, reliable, easy to maintain, easy to tweak and custom stuff. So the only thing is in both exact image or our other stuff and mini-SED, it's of course very systematic, right? Very repetitive of the same, because you have only one SED binary and you can basically have SED command stuff. By the way, we could have, maybe I should rename the stuff from SED to command. Anyway, not a matter. So very regular stuff. And the only thing is here, it's a little bit in testing T2, it's a little more involved because the test will do different things. So, and we can't test, like also there will be architecture specific tests, especially when we script. By the way, maybe I should make a note here of even test expect installing the whole. So that will be a little bit. Just this dozen tests will take weeks to implement, especially with all the whole installation scripting. To my surprise, somehow I think previously something segmentation faulted. This was either Spark. I forgot which it was, but I was surprised. I tested that yesterday or so. That Spark did work. I thought it didn't. Yeah, something previously segmentation faulted, so I have no idea why that works now. Maybe some QEMU regression fixed. Anyway, so we need to also think about some kind of pattern, because I mean, it probably will be similar for all the commands. So maybe we export some variables like QEMU and QEMU system. How did I name that here? Here QEMU system here. So yeah, it's also called. So that when we run the test could conditionalize, because the problem is how to conditionalize, like control that some of the stuff is only executed when it's available. You could do this with file naming or subdirectories, like, but that would also be ugly. Ugly and ugly, but I mean, you could make a subdirectory like QEMU and QEMU system and then only run those, but you lose somewhat overview. In my opinion, I like to keep stuff in one directory because otherwise it's like always annoying to navigate and keep an overview. So the tests would be, so usually I use it also here, no, not here in mini SED, but in exact image I use like 3-digit numbers, and then it's like 001, like basic stuff, or like 100 like TIFF image files, and then like 200 is ping files and stuff. And maybe we do something here, and the tests, for example, if they need QEMU, I mean, if the test would then be test result, okay, fail, or not applicable, right? So that the tests, I think it's best then to include, because all the tests will be so different, whether they can run or not. Maybe even architecture, obviously, we need to see how we pass the stuff down. Because the stuff even needs to know the architecture at times to, for example, script installation, because the installation test stuff would need to partition differently or other stuff, or even at times run kernel. If you want to test boot the kernel, that probably will be some case switch of having quite different architecture-specific quirks and features there to configure QEMU to produce some working configuration. So I guess we could even, like, if we group the stuff, like maybe 0. I leave that here. So we could like just, it doesn't really matter much, but just to give you an example that like 0, 0, like 0, 0 something could be basic tests, like basic binaries and stuff. And the numbers don't need to be unique. What I usually do is like number, like an exact image, like have the file name similar to mini SED, to have the test case title still in the file name to make it easy to look up and stuff, and the numbers just for sorting and deterministic running them in some order. So you could have, if you run out of numbers, like let's say we do this for a decade, another decade, obviously live here on this channel, which you probably want to share, like, and subscribe for, and we eventually have more than 100 tests, that wouldn't be much of an issue for me. We could just use some numbers twice, it doesn't really matter much. And because the file name will be different, right? So we could have, if we ever have more than 100 basic tests, it could still be 050 and having like 050, like let's say bin utils, AD or LD and stuff, have different titles of the test, right? So, and still use the number just for a little bit of sorting and have them in some order. And refer, like speaking to a colleague, like test case 50 fails for whatever, right? And still make it, even if you have like two handful of tests, still have it easy to communicate of, hey, test case 50 fails for bin utils, Itanium, whatever, MIPS, right? Like we could have here 100 something Linux kernel or other kernels, like 200 install. Actually, we could then probably maybe even different sorting here. We could have this root fs first, so yeah, this is kernel stuff, right? That could be part of the kernel tests. That would be install stuff. So not make this last, but in here. And we could even also, maybe we even make this, where we have install, we could even make this like 500 something, because maybe other simple test is more interesting. Maybe also binary size. See how this sorting comes in handy, right? So immediately much nicer grouping. Binary test is certainly a very common thing. Actually, yeah, it's not the most important. Yeah. Most important would be, I usually like to group also a little bit of importance, right? So that first, like the 0 basic test run for do the binaries even freaking work. And so install does low memory install stuff, init or deboot. I mean, theoretically, that could be a kernel. Yeah, no, let's leave it here. It's kind of a kernel and init RD test, but let's leave it here. Actually, we could, let's make this a little bit earlier, and then like maybe 500 system, then like 500 system stuff. And this install stuff could have multiple tests, right? We could have different test cases for installing on all the architectures. Maybe this is also, yeah, we will see when we work on it. Maybe it's easier to make PowerPC and x86 two different tests. Depends on how to reuse all the scripted installation data. Maybe you can reuse it in expect or whatever you use them for that. 500 would be system tests. We could later change this around depending on how we set this up. Do we run, maybe it's easier. Where's even our full install thing? Where did I move that now? Or did I copy that and delete that? No. Did I not hit a full? Not sure what I did. Boot or so. Maybe it is easiest to directly run, or like not easiest but fastest to directly run those in-system things first, because installation takes the longest. And this is another why I group them then, so that first the basic tests, they're also like done in fractions of a second, and maybe we need to set them up here with bin format misc. We need to see. It's certainly the easiest thing to directly run them from your workstation's file system, so that you don't need to have the full installation just for our testing time, so that if you wait like a minute, then most tests are run and you already know if this ISO and architecture is like good to go, and then you can go drink a coffee and wait for the installation. Because a full installation, even if it's like minimal exoc, minimal exoc nowadays with GCC, like Linux kernel, Linux firmware, which is also huge, glibc, then LLVM, Clang, Rust, exoc server, Mesa, and all those huge packages, 100 megabyte or 70 megabyte compressed, hundreds of megabyte extracted. Stuff takes forever. I'm actually surprised how slow QEMU is at times. I always praise QEMU for its versatility, but it's freaking slow. I understand it's super complex, and it kind of need to be thankful that the stuff exists at all, but I wonder it's a little bit slowish. I would expect that like a freaking epic thread ripping 1550X runs is a little bit more smooth. I find it a little bit mismatched or strange that the latest, fastest enthusiast Ryzen does emulate this at like feeling like 200 megahertz. I need to check with the real system, but like, or maybe 500 megahertz. But yes, it's basically, it feels ballpark like at least 10 times, like 5 gigahertz, not even 5 gigahertz, like to 500 megahertz emulated. It takes forever to install. Native KVM install like installs in less than 4 minutes or stuff, and then this installs like in 25 minutes or so. Something of that. Yeah, so the network boot real hardware, that's certainly a little bit independent test. So what did we got here? Yeah, this kind of stuff. So that would be the goal. And the goal is, of course, that when we upload ISOs, we now had the times that. And why do I do this today? I mean, I worked a little bit on that the last, or like brainstormed a little bit and prepared with my scripting here. The last weeks at times, because we sometimes build stuff and then people in our Discords like, yeah, YOLO, this stuff doesn't boot and stuff, right? And certainly can't test all of this stuff manually. So that is the only, not only the only constant is change, but the only replacement for testing is more testing stuff, or so automated testing is more automation. So build all. We need, I mean, maybe we could, let's maybe try to, how long do we, so but that's basically the summary. A summary is 30 minutes. Some of the stuff always takes, even the summary, right? Just explaining all the thought process. I hope you find this interesting, learn something. And certainly don't forget to like and subscribe for that. Configuration create errors, so let's comment this out. I also need to vastly improve this test drivers, not to constantly have to comment that out here. Where is our build target? Here. They should be mostly there, and then so here let's run that. So I had here already prepared, if we have QEMU, then build ID run this QEMU here for a test. So that would be the first basic test, right? That one here. All right, I also wanted to do profiling. You know what? Let's run that for the simple reason to get an overview that our QEMU scripting works. And maybe then in 5 or 10 minutes we nearly called it a day already. Amazing that some people tune in. That is always makes me happy. As always, don't forget to share, like, and subscribe. Maybe we should pipe that help output to dev null or something, because right now it's a little bit difficult to see if there was some error. So I basically only wanted to do that to see that all of those QEMUs exist, to potentially fix there some scripting. We also need to shuffle that a little bit around, because ideally, because the last days I also built MIP64 instead of N32 with N64, and then it needs another QEMU. It would be amazing if we automate that as well. So do we not have any QEMU arc? No. Microblaze we have though. Yeah, X32 we also don't have. Let's perhaps, so again, this output was only to, what would it be, system, to see that it works. Does it write to, or does it have like some version? It has some version. Okay, cool. It's crazy how slowish that is. Also, granted, most of this is our shell-based config shell scripting. Maybe we need some just-in-time compiled shell, high-performance shell another day. So that is much better. So we have here the output also of the QEMU binary names somewhere here. QEMU even Hewlett Packard Precision Architecture, apparently. There is something core dumped. Which one was it? HPPA? Motorola 68K? Wait, it Oh, this is really interesting. Yeah, that I find it always a little bit surprising. I mean, sure, binary emulation and stuff is super complex, but you would think with all the thousands of people who ever worked on QEMU that this stuff is in the meantime bug-free. So that is Motorola 68. Oh, Spark also. Okay, so I remembered that correctly. Just that it is the 32-bit. All right, it was. Why does that fail though? Okay, we have two that fail. So it was 32-bit Spark. So I remember that sort of correct. And theoretically, this could also improve upstream QEMU, right? Maybe if we make some efforts of reporting that. Maybe I should power. Actually, this binary should, of course, the Spark binary. I don't even need to power on my slow Spark Station 2. I can directly power on some Ultra Spark. Also with spring heat records in Europe and probably most of the world, don't forget to hydrate. Motorola 68K. That is really bad. But does it already do something? No, its segmentation faults instantly. That is funny. Funny. Maybe it needs some other. I mean, it should probably work. What was this? Price away. Not sure what it emulates by default. I wish this would be at times a little bit. Okay, that's not that. Whatever it's going on there. So basically that will fail. I think someone, was it the Graver, someone tested that on the real Amiga, right? Some year ago. Yeah, comment there. Happy to see that we developed a test infrastructure. So the question is, I mean, we could, what do we do now with those two? Maybe we how did we call this usually? Tests? Did I always call this? I think at exact image I call this test suite. Alright, because there we have a test directory for example scripts or stuff. At least I thought so, whatever. And so neat. It's a pity. I would like to, I mean, when I started our portable UI and runtime stuff, I actually wanted to use that name that Unity or stuff until it's this Unity thing. And then later I thought, let's call it one, because obviously we have T2 and there's like one API and stuff, and like Intel grabbed this bloody one. Like, does someone even use this stuff from Intel there, this one API stuff? But I mean, not that it would stop our own stuff to call our own stuff internally one, but yeah. But anyway, a little bit annoying naming. So what do we have? We have also test. What do we have in here though? This were older tests of, yeah, okay. Okay, so at times test suite, otherwise tests, yeah, that's probably fine. And let's maybe copy the mini SED test thing here. And let's maybe copy one. So let's name this 001. We can rename this. call it basic for now. We can later rename this to something more amazing. And so the problem is, so first of all, we rename that sed to command. And okay, here we have eConvert with that stuff. So what we need is like QEMU, and so we have some complications here. That we don't always have QEMU, and here we would need maybe we make the calling convention, because we have quite some data to pass, not only the QEMU, also the sandbox root. I mean, we could export some reasonable named stuff like this root or so, or just root. Wait, we also here, and like, does it even? The thing is with that, maybe we should just, and there you see the complexity, right? It's always starting some new stuff always takes the most time in the design process, because you have quite some conditionals. Maybe it's easier to just run this as shell. And because we have some tests that would want to run in the sysroot, we have like the newly built system sandbox, we have some tests that would want to build with the ISO. So to make this most flexible, because we have different kind of test sets, maybe it's the best thing to just run it like that shell script then, and manually, like in this basic tests, if you want to test in the sysroot, change there. Maybe that makes the most sense. Then we would have dot here, and here I would want, I had this prepared already. Prepared, like a one-liner. Here or here, exactly that. I'll write with D. And so I do that because explicitly, I mean, this tests multiple things, right? This simple test already tests that QEMU works, the executable works, with the executable, the dynamic linker works, and argument passing works, and like basically all the most basic low-level stuff needs to work for that, including QEMU. So it looks simple, and it looks more simple than it is. And I explicitly specify some direction, because if we list all the builds have different directories, right? So listing all, then we wouldn't have some deterministic output, because they all have different lib variants from multi-lib variants of lib32 and libx32 and lib whatever, lib or lib64. And so not listing any of those, like we always have procdef, this, temp, and basically that's it. And then actually, probably usually they don't need inputs. So this is the SED. By the way, a nice thing to list files is, by the way, is grep. Why is this, by the way, so strange? No, whatever, it doesn't matter. So then, by the way, a nice way to get an overview. A little pro tip of what I use for decades. Grep dot to match anything, and then grep outputs this file header there. So this is SED input output, just to test some basic stuff there. And so we don't need input, and the output should be that one. So usually you can manually pre-fill that, or you create infrastructure to save that. But obviously you, in your test suite, you usually have input, output, input and expected output. We could even name that doesn't matter too much though, but yeah, okay, fine, whatever. Let's name that 00, yeah, 1 bin ls or so, or ls-d, or just oops, what? Let's say something collision. MMV is, by the way, an interesting program that probably most people don't use. It's usually not even a base install thing. I wish this multi-move functionality would be integrated by now in standard Unix bin move, but it's not. Comment there, best program to watch, increase your poster and drone. What? Anyway, hope you learned something. Happy or not happy to use it, but anyway, share, like, and subscribe's welcome. But I seriously hope that you learned something, because more main channels there yesterday. Bad code scares me, so I hope everyone learns too. Something to program a better world. So the test binary, again, there are huge unit testing frameworks. I'm not a fan of most of them. I like my stuff stupid simple, so some 100 lines of shellcode do it for me. And so this is probably copy and paste some more advanced stuff from exact image. We need to do here some scripting to export this route. Actually, let's try what happens here. So what did I program here previously? All right, we have here, so we named this to command, because obviously we're not testing SED. So it's reading that for command. Okay, we also want to change that to run this with shell. This is because we run all this through mini SED. Also, we might not always have inputs, so we need to script this differently later. And this also has some timing thing, I mean just with time, and does it have some inexact image? I have automatically populating the expected data for new files. Probably need to copy that another night. Oh, wait a second, this has even some shebang detection here. Then eval 1 command. Okay, this expects because this was expecting an SED. We obviously don't need that anymore, so verbose time. Yeah, we don't need that anymore. Wait a second. Okay, this was first argument. So that was somewhere here. Why did we? Okay, this is Okay, I see. That was testing, that was supporting testing arguments. So we don't really need that here, so we probably want to run those directly. Maybe even with the shell. Maybe later we could script to use a specified shell or something. We don't have one argument here. Input, if any, does it hurt if we... Maybe remove that for now. Okay, we need... So for that we need to at least export this route. So let's see what happens if we run that. It of course will fail. Let's see what happens if we define our QEMU for x86 here. Of course, later our build all driver will export that, and this route equals serve t2 clean build x86 22.5. It still fails. More. Then let's extract that. Okay, we scripted there some nonsense. Oh wait, bin actually. There is this command is specified twice, probably because previously we substituted some SED away. Here it is. Failed with compare running. What exactly happens there? Should we simply source those files? Maybe we should. I mean, we could leak the drawback is we could leak stuff into the environment. QEMU this route. What's wrong with that? Okay, that works though. Did I? Maybe the dash F is. I know this also. How did we run this? We did run this. Wait, error. Why does this fail? Did we not implement verbose? Let's see. Here's verbose, so where is verbose equals 1 div u? Why don't we run diff, compare stuff failed? Somehow this verbose doesn't. Oh wait, the verbose is the default. Why is this? Oh wait. Why is this reversed? Maybe. Apparently did that intentionally. This simply, okay, that lists that. Interesting. Okay, it does work, but there you see, I mean, maybe, not sure for what reason I revert that. Maybe I always wanted to see that by default and wanted to suppress the verbose. Apparently must have been the case. Anyway, so in this scheme I would want something like that. It's of course just the beginning. Slightly wonder should Why is this highlighted differently? So then now the test passes. We had here, okay, so why does it, is it alphabetically listed? Apparently it is, huh? I would have expected, apparently, yeah, you always after 20 years learn something new. Apparently this is sorted, even if you specify those manually, it sorts them apparently. List entries in directory order. I wouldn't rely on this, so probably we leave it like that. And maybe we actually try that already. Maybe we symlink that for now. Not yet sure where I will place those. And because I probably don't want to ship the test suite in the regular T2 source distribution. Okay, commons T2 legacy. Is that x86 or 32-bit or 64-bit? Where exactly does it not boot? I usually test them in QEMU here, obviously. I mean, very theoretically, we could, even if we would want to, not all of those tests would be QEMU, right? Actually, let's add a note to that. Because, for example, we could test some SGI stuff with QEMU or and then those tests would, as I said, this is why I hesitated to hard code naming conventions for testing with QEMU or stuff, because we don't have that for everything. Or we could test Itanium with, what is the emulator, Sky? Or whatever. Called Sky or stuff. Or Zemix, wasn't one Sky? Whatever. Or other such emulators. And what else? We could even test some other, like, whatever, other exotic vintage stuff with even MAME. They even also have some SGI Indie or something of that sort. So, yeah. Or actually, wait a second, I wanted to make... We could even test... I mean, very theoretically, some tests could be optional, like if you have that installed. We could also test with like only one, because we don't really care about VirtualBox, but we could test with VirtualBox. By the way, I wonder, is PC emulator emulating all protected mode in such a way that it can boot Linux? How to install PC? No, I want the opposite. I want... Anyway, that's not the most important, because x86 is the most tested, but VMware or stuff, was it even written like that? Personally, not the most invested into that. I have a license. I think I have one license for VMware, but that is for macOS from a decade ago, when I was kind of ignoring desktop Linux because the state of desktop Linux a decade ago was so meh. So I have a VMware Mac license, but it doesn't help me the most with that testing. I also have at least a parallel from back in the day. Oh wait, we could even other tests, other crazy tests like... So I'm personally not the most parallels. I think this is a waste of time for the most part, but we could test with Mac OS native ARM and Xhive or so, or other BSD stuff, obviously. But yeah, just some ideas. So we had QEMU, we have some this route. Then let's try to run this test. So let's, well, this is only the first test, obviously, but so much you can get done in 1 hour. And oops. So here would be this stuff, and so what we would do is export this route equals has the ID the whole. Here we have this already. So that's not, obviously we don't hard code that here. We have QEMU. We might have QEMU. Export this route later more, like the ISO. Like to do ISO name. We have that here somewhere. Maybe we already use that. Here is the ISO name. Maybe we actually capitalize. I mean, I hate capitalized variable names though. Can export to? I would hope so. So actually, wait a second. We have. Oops. This rule is anyway not capitalized, so we could also export ISO something. So this we have now finally kind of sort a little bit more properly implemented. So and then run all with this route ISO, and theoretically the architecture, how do we want to, so architecture is in Arch. That is not the real architecture name though. Maybe, by the way, we probably do we export SDE config Arch? Apparently not. I would also not want to use this SDE config prefix in the test, so we could export that. I mean, maybe, you know what, maybe I prefer this, like, I think I prefer like normally locally named variables lowercase and maybe like more global whatever stuff, or caps or stuff that you see like, but I need to use it some days. Is this the whole, that is the whole, maybe we prefix this, maybe we make this a current working directory ISO, because we cd into the test and it otherwise wouldn't work. So something like that, and oops. Okay, QEMU was capital already, and so the only thing is we would, here's this route. We would somehow need to signal not applicable. For example, in this test, like if QEMU is not set, we would need some special return code. Like maybe I don't know, something that's usually not necessarily accidentally returns there from QEMU. So maybe something like, I mean, 0 and 1 are usually used. We could use 2, but maybe we use that for now. Maybe we test that actually, and let's run that. Oops, let's run that. Why does it not work? What have I done? Which is empty. What? x86. Ah, right, because we changed the name of that. And so then if QEMU is not set, we would check the exit code here. Again, we don't hard code that here because other tests could rely on VirtualBox, GX, emulation and stuff. And so there might be various combinations of what might not be supported there. Not applicable. And where do we always, so errors are here. We would theoretically, okay, we only count the errors here. It's of course not really an error though. Okay, that apparently, I didn't change this thing to elif. Hello, what have I? So, not applicable, that is amazing. Of course it doesn't count as error, and theoretically I think, and welcome everyone, welcome to Granular, in my exact image stuff we could count the test differently. We could, if we later have more than a dozen tests, we could count the tests, and we could in that case like subtract that from the total test count. If it's test we couldn't run that, it shows like, for example, 10 or 50, and if those tests are not applicable, like subtract them, so it does only show like 10 errors from 20 or something if 30 tests with QEMU are not applicable. So then let's see what happens if we run that. Of course, later we could have other continuous integration. We could set up a server that it's testing stuff with commits and stuff. It's more professional and we grow and so on. But for today, that is all I wanted. And let's see what's happened with this stuff there. There it said something not applicable, so something doesn't quite work yet. QEMU, ABI, okay, something, oops. Maybe QEMU is not capitalized. Alright, QEMU is not capitalized. Oh, wait a second, did we even capitalize it? Test 001 command. Ah, yeah, we had this capitalized, obviously. Yeah, I mean, some stuff, okay, this route we don't have ISO. Yeah, I think this is quite reasonable to do it like that. I mean, QEMU we only use here, we could directly all cap that another day, but otherwise also not the worst thing to QEMU this to export some stuff here. Let's see what we have there. And welcome everyone. All right, I heard once, indeed, Also the tests somehow fail, we have still something done wrong. That indeed is the thing, but this is also upstream regressions, right? If you wonder why I constantly criticize stuff and point out imperfections, sense like, yeah, sorry to say that there are also imperfections and upstream stuff is broken. Probably something else, what could still... it's this thing here, this also needs, oops, I know this already. It could be more, but this also needs current working directory prefix to work. Because otherwise it tries to change directory into, hey, there's a test pass. There, that failed. Why does it fail? We need to check. Okay, more tests fail. Let's run this verbose to see why. It could be as simple as sorting order. Maybe they... No, it actually should be sorted. Why does this stuff... Image, not for this architecture. Oh, interesting. Okay, there it outputs this config cache is corrupted. That is bizarre. Oh, wait, the config cache. Okay, need to check that. So yeah, but this is the stuff you have some ideas, you first implement it, and then some unexpected stuff happens. I wonder, I mean, maybe we need to patch QEMU. I saw some month ago that it doesn't have some integrated change root stuff. I checked that already. For example, here's this corrupted LDSO config cache thing. By the way, I still need to shop some food in some minute before the grocery stores close here. It's the main one soon. Also, x32 we can't test like that. So some stuff passes. Where do we have failed stuff? And what do we have here? Okay, this is Motor 68K. Someone, if you want to have something to do upstream, you can debug that in QEMU. Spark, also known. And here is LDSO cache is corrupted. So we actually, this is also a really crazy one. It shouldn't so it's loading the system LDSO cache. It's of course not ideal. So there is still some imperfections to improve. So this is also a crazy one. This is simply trying to load the wrong. I think it's trying to load that. What we basically would need is some integrated change root wrapper, to be honest. So this would fix both of those issues. I think this is just trying to load that from the host system or stuff and doesn't have the file instead of like from the sandbox. What else do we have here? I mean, otherwise it looks quite reasonable. What do we have there? This could be the last old run potentially. Or is it? Maybe too much output. Yeah, one thing that is, of course, with all the output, we probably would want to work on streamlining this output, better formatting, summary, and so on. But that is otherwise for another day. So we implemented the first test. That is amazing. It took only a little bit, like with summary, 1 hour, entertaining you on YouTube. So that is done. I guess we can delete it here, right? Test basic thing like ls. Select there. We have it. So yeah, that's it for this video. I hope you learned something. That is, yeah, microkernel, so more low-level stuff, and so on. But a little bit of quality of life improvements for myself. What we probably could add a note here is somehow QEMU change root file prefix something for this test to work better, and those two that currently fail already. But otherwise, yeah, that's my ideas for more testing. If you have more stuff, maybe for the fun, yeah, so the basic stuff is there. If you want to script more patches, pull requests welcome. There are also these bounties to work on, right? More main channel and GitHub issues. And otherwise, maybe I try to do some X frame buffer stuff next, just because I would also want to have some Firefox testing. Testing Firefox is of course not easy because it just shows some stupid splash screen. So as if testing the browser would not be difficult enough, comparing an ever-changing splash screen with like, hey, we are Mozilla and Firefox is the greatest and stuff. Certainly not the most helpful, so we would need to find some solution for that. Maybe script it simply so to open the website. Although I hope Firefox doesn't show it's the first use of, it's not the default browser. Like the problems of testing sophisticated applications, right? Bloody test screen, which might not be easy to get away. Maybe stimulating mouse clicks and stuff. If it's like mandatory to show this bloody splash screen, if we can't run Firefox some HTML file for some testing, if it then also still shows not yet the default browser, first run, welcome to FactSwitch. This is the stuff. Testing engineer, right? People always think like testing engineer, it's also sophisticated stuff, right? So much stuff to think about, also technology fuzzing. So like this is only the beginning, right? So really you could fuzz the heck out of it. There is so much stuff in testing, but that's too much for this video. So that's it for this video today. I hope you learned something. Don't forget to subscribe. And if you're bored and otherwise too hot to do something, there are plenty of more videos, right? 3 years of random videos and more main channel. And otherwise, stay hydrated and I hope you learned something. See you next time.